Hello everyone, welcome to this session Kubernetes feature of network policy with Calico. Before starting this session, please subscribe my channel so you'll never miss any updates from me. Let's begin. What we are going to cover in this session. So session description is here. This session covers the Kubernetes feature of network policy. The hands-on utilize the kops installer to create a cluster using the Calico network overlay. You will be guided through the process of first creating a network policy that restrict pod access followed by another policy that grant pod access to certain client and named server. And this is the agenda for hands-on lab. So here we are going to utilize kops to create a cluster, create a demo policy namespace. We are going to deploy Nginx and we are going to expose and port 80. We are going to create a deny policy to test it, and then we are going to allow policy to test it. So this is the scenario. So basically in this scenario, we are going to come as a bastion host, and there is a script that run kops on Kubernetes operations, and that will create Kubernetes cluster, and the script passes the network Calico to that command so that it will configure the cluster with Calico network overlay. And we have to do this with Calico, as Calico support network policy, whereas the default like Flannel does not support network policies. Once our cluster is ready, we'll create demo policy namespace and we'll deploy the few replica of Nginx web server. I will demonstrate that you will have access of those pods by default, but once you enable the deny all network policy in namespace, you will notice that it will act like a firewall. You can't access the pod without the allowed policy rules. You need the access to reach these pods. So that means you need a access rules. And I'm going to demonstrate a network policy that allow access the pod where the Nginx web server is running. And finally, I will show you that other than the allowed policy, no one can access the pods. So let's begin the hands-on lab. Here you can see this is the command set I'm going to utilize particularly for this session, and I was talking about the kops cluster script. So this k8s create.sh script that you can utilize to create a cluster. You can find this script on my GitHub repository. So here is the address you can see of my GitHub repository. So here you will find the create.sh script, default deny YAML file, and access nginx YAML file. So let's begin. So I think session is out. Let me initiate it, restart the session, log in as a cloud user, and I do have a password for it. So I'm to copy it, and here I am. So I'm using Amazon Linux AMI here. So it's clear. So if you see where is the script, script should be in home directory. Here you can see I have a script in home directory k8s-create.sh. So let's run it. So dot space dot slash k8 create.sh, and it's started. So here we are going to create a cluster. Command runs successfully. Now update the command. Okay, let me clear the screen for you. So kops update cluster -y. Okay, so it started, and it's going to take some time. It will take probably between 10 to 15 minutes to make the cluster up and running. So it says cluster is starting. So let's validate the cluster. So the command is kops validate cluster, and yes, the error is expected because it is still working on cluster. So I say validation failed, and if you keep running this command, it will keep giving you different error, or maybe the same error, unless our cluster is not ready. So let's wait for to cluster get ready. Let me clear the screen. Again run validate cluster, verification failed. Again it's the same error, so we have to wait for it. Let me try again. Again it's a validation failed. So I'm just going to fast forward this video and we'll come back once the cluster is ready. Okay, so I'm back now, and here you can see our cluster is up and running. Our cluster is ready. So you can verify it. kubectl get node, and here you can see we have master and two nodes running. So now we are going to configure the required namespace. So let's create the policy. So kube. Okay, let me clear the terminal. It look fresh. kubectl create ns namespace demo hyphen policy policy. It's not necessary you should give name demo policy. You can give name of your choice. So is created. Now we have to run two replica of web server. So we are going to use nginx. So kubectl run hyphen name space equal to demo hyphen policy policy. Server name hyphen nav. You give replica count. I'm giving here 2 as I mentioned. You can give a number hyphen image. So we are going to use nginx, and oh, I think something's wrong. kubectl run hyphen namespace equal to demo policy nginx. Okay, I know. So not replicas, must be replicas, and it's created. So I'm going to clear the terminal, and we are going to expose the services on port 80. So kubectl expose command hyphen name space equal to demo policy, and get deployment name must be nginx hyphen port equal to 80. So port exposed. Now we are going to run an interactive session in a pod called access using the busybox images. So kubectl and it's very interesting. Few people call it kubectl, few people call this kubectl, but I'm going to call it kubectl. Hyphen name space. Oops. Or policy access, and I'm going to use busybox image here slash bin and get the shell of it, shell, and here we are inside the cell. So you will see when I'll run a command wget when q x hyphen o hyphen, you must see the HTML raw format or a raw HTML response from this command. So that means we have this pod have a access of, I mean this policy have access of the pods. Okay, so go out, and now okay the terminal. Now we are going to enable the isolation for it. So I'm just going to run an interactive session in a pod called access using the busybox images. But before that, let me get the raw policy for default deny. So if you go to the default deny policy, here you can get the raw, you can get the URL for it, and you just simply paste it with the command wget, and that's done. So if you want to see the content, what it says, what it has, default deny YAML. So here you can see the default deny, the namespace is demo policy, matchlabs curly braces, that means all deny. So now let's apply it. So kubectl create minus or hyphen f, sorry, default deny YAML. Okay, so policy has been created. So now kubectl hyphen hyphen namespace, sorry, equal to demo policy get pod. So you can see the pod over kubectl hyphen hyphen namespace demo policy get pods. Oops. kubectl demo policy 100 pods. Okay, so you can see these two pods are up and running. So now I'm going to run an interactive session. I mean I'm going to run a busybox images, or not images, image for it. View ctl run hyphen name space is equal to demo policy access rm image busybox and then bin cell. So we are inside the pod. Mm, ah, Seems some problem with my internet. Let's wait for it. Okay, so now we are inside the container and we are going to test the container whether we do have access or not. So command is wget f1q f1 time out equal to 5 seconds. Server name f1. So let's wait. And here you can see we have a download timeout because now we have enabled the isolation policies, so that means it will not allow us to access the pod. So now go out from this container. Now we are going to create a access policy. So again we need the raw file of access policy. Let's go back. Here I have access nginx YAML and I can get the link of raw file. So let me copy it. Again I'm going it here. I'm going to wget command, resource created, and if you want to see content of access file, you can see name access nginx policy demo policy, run nginx pod selector match level, and run access. So clear the terminal, apply it, kubectl, create, uh, access YAML is created. Now we have to verify the access to nginx server. So let's go inside it, kubectl run hyphen name space equal to demo policy access rm ti hyphen image name is busybox slash bin, and we are going to an interactive session. So we are inside the cell. Again we'll test it. So we should have a access of nginx server. So let's see, wget hyphen q x. Now you can see the HTML content, the raw HTML contents. That means this policy is working. So let's go out. Now I'm going to perform a last section of this session. which is I'm just going to change the policy name or access to the wrong person, and then we can check whether we still have access of our pod or not. So let's run kubectl run namespace equal to demo policy, and instead of giving access I'm changing it to wrong access. Okay, wrong access. rm dr image. Again we are going to run the same busybox image slash bin slash such. This wrong. Demo policy. Okay, so I'm trying one more time, and here we are inside the container. So now test it. Command wget and q timeout. Given 5 seconds, and let's wait. Okay, so we can see session is timed out. That means this wrong access does not have policy approval to access the container. So guys, that's all about for this session. Thanks for watching.